Alright, so in yesterday's lecture, we have learned about salt hydrolysis. Okay, we know that salt also has its own pH. So we have neutral salt. We can also have acidic and basic salt. Okay, all right. So to find the pH of the salt, okay, to find the pH of the salt, the first thing that you need to do is you have to dissociate. Okay, you have to make sure that the salt need to be dissociated first. Okay, all right. So look at this example. So we have 3 salts given to us. So in order to determine the type of salt for this given salt, okay, so the first step will be to dissociate the component of the salt first, okay, into its ions, and then from there we are going to choose which of these 2 ions that will undergo hydrolysis. That means it will react with water to produce H3O plus or OH minus. Okay, all right. So normally the conjugate that come from the strong, either strong acid or strong base, will not going to react, will not be reacted with water. Okay, that means it will not. It is very weak, and because of that, it will not react with water. Okay, take for example, NH4I. So we can predict that this salt is produced from NH3 and HI. So HI is a strong acid. So HI will produce its conjugate. It is an acid, right? HI is an acid, so the conjugate base will be the I minus. This one. This is the conjugate base of acid. Okay, so this one will not be hydrolyzed, but this one, which come from weak base, it will hydrolyze. Okay, remember last time the conjugate base pair, if we have weak base, that means the conjugate, if we have weak, that means the conjugate, its conjugate will be stronger than the original form of the acid or base. Okay, all right. So NH4 plus in this case will undergo hydrolysis. Okay, so please be careful on the arrow use. Okay, for the salt dissociation, it should be one-headed arrow ataupun single arrow. Whereas for hydrolysis, okay, you have to use double-headed arrow, the reversible arrow. Okay, all right. So that is from here we could see that it produces H3O plus. Okay, and therefore this salt is said to be acidic salt. Okay, so earlier on pun kita dah predict that NH4I should be acidic salt because, okay, so this is like your monologue, your inside monologue. Maksudnya we don't usually write this down. The one that we write ataupun on paper would be this salt dissociation and hydrolysis. Tapi untuk kita punya lebih cepat, lebih mudah, lebih senang, okay, kita boleh dapatkan the prediction of the characteristic of salt by having the reaction between the acid and the base of the salt. Okay, the component of the salt. So NH3 is weak base, HI is strong acid, so the salt will be acidic. Okay, so that will be our prediction. So kita provekan, maksudnya at the end you should be producing H3O plus, and it is proven that the salt is acidic. Okay, all right. So when it involves calculation, so when it involves calculation, later on you have to calculate the pH, right? So you have to calculate the pH. That means later you will be needing the Ka because you produce the H3O plus. That means you will need the Ka of NH4 plus. Okay, if you are given the Kb, you need to convert the Kb given into Ka, then only you can use it to find the H3O plus and finally find the pH. Okay, all right, so we have a checkpoint. We have two checkpoints for this one. Calculate the pH of 0.5 molar CH3COOK solution. Okay, so this is a salt. Okay, if you could predict, this is the salt produced from a reaction of CH3COOH plus KOH. So this is strong base, this is weak acid. So it will produce, okay, our prediction, the salt will be, what's the characteristic of this salt, guys?
Basic salt.
Basic salt. Okay, thank you. So the salt produced should be a basic salt. Bila you dah ada basic salt terus, okay, bila you buat equation, you should be producing OH minus, and then you will be needing Kb, and then later you will be calculating for pOH, and then lastly only you can calculate for pH. So that's the plan tau, dia punya strategi dia tu. Okay, alright, so okay, so let's start from the garam itself, from the salt itself. Okay, so first thing first, so okay, let's go through the question first. Madam is very gelabah. Okay, read the question first. Determine whether the solution is acidic, basic or neutral. Definitely not neutral one. Okay, so given the Ka of this acid is this value, so this is the Ka for this one. Okay, what you want is a Kb of CH3COO minus. So this one would be the Kb lah. Okay, so you can find out the value of the Kb. So simple saja. So Kw is equal to Ka times Kb. Okay, so you want to find out the Kb, right? So Kw over Ka, you will get the Kb. So you have this value already, and this is also given to you. So you can find out the Kb lah. Okay, because what you want is CH3COO minus, because later this salt will produce this anion. Okay, all right. So this is just to prepare this is just to make sure that you produce you need Kb lah. Okay, you will be needing the Kb. So this is the step. Okay, alright. So let's start from CH3COOH. Kita dah predict dia basic just now. So this is the time for you to prove it. Okay, alright. So let's start with the salt dissociation first. CH3COOK. Okay, aqueous undergoes salt dissociation. So this is the one that we call salt dissociation, producing the components of the salt. CH3COO minus plus also aqueous and Ka plus. Okay, all right. So this K plus comes from strong base. So this is a conjugate acid of strong base. Therefore, it will not be hydrolyzed. Okay, but this one will be hydrolyzed. Okay, this later on will undergo hydrolysis of salt. Okay. That means it will react with water to produce, okay, just now we predict that it should be basic, right? So you siap-siap je letakkan OH minus there. Okay, itu yang penting ni kita punya prediction tu. Tak adalah kita mencari-cari acidic ke basic ke, okay? So it should be basic, aqueous. Alright, so since this is OH minus, okay, so this is the conjugate base, conjugate base of this acid, right? So it will accept the hydrogen from H2O. Okay, it's the conjugate base. Base is proton acceptor, so it will accept proton from hydrogen, and at the end, H2O will become OH minus. Okay, so it becomes CH3COOH. Initially, it is -1. Okay, final, okay, it becomes 0 because it accepts proton, right? Okay, so this is the equation. Okay, alright, so kita nak insert the concentration and whatnot, because we want to calculate the pH. We want the value of the pH just now. We don't simply want, okay, this is basic, this is acidic, macam tu. Basic can be from 7.1 until 14. How basic is basic? Okay, so you have to we need a value for this. Okay, alright, so in order to solve for, because we want to find the OH minus later kan, kita nak cari OH minus, in order to have this value later on, we need to have this value lah dulu kan, betul tak? In order to have this value, kita kena patah balik, rewind dekat salt dissociation. Okay, alright, so in the question, it is given that the 0.5 molar of the salt solution. That means, initially, the salt solution is 0.5 molar. Since it dissociates fully in water, so this is initial. That means before the dissociation. After the dissociation has taken place, this one will be equal to 0. That means almost all of the salt will dissociate. Okay, that's why bila dia dissociate, almost all dissociate, at the end dia akan jadi 0. There's no salt left in the solution. Okay, so all has been transformed into its component, which is 0.5 molar. Okay, luckily dia dah bagi dalam molar, siap-siap Kalau saja-saja dia bagi dalam salt punya mass, okay, and volume, you have to calculate the concentration first. Okay, alright, so that is why this arrow is very important. It allows us to predict whether the reaction proceed to completion or not. So in this case, dia proceed to completion. Maksudnya dia habis, dia stop. It will not be reversed. Okay, alright. So since we have this value 0.5 molar, we can carry this value into the second step of salt hydrolysis. So we have this one. Okay, 0.5 molar. If you were to use ice tables, very simple. Okay, initially it is 0. After a while, it becomes -x. This one positive x. Okay, sebab kebanyakannya semua 1:1 ratio. Okay, kebanyakannya x. Okay, alright. So from here, this is just for us to see everything. Everything is in the table. Okay, next we can proceed to using the simplifying assumption, the simplifying method, or the alternative method, which we can use the formula. Okay, alright. So since we have OH minus, so we are going to be using the OH minus punya formula is equal to Kb times C. Okay, so Kb we have determined it just now. OH C is 0.5 molar. Kb berapa ya? Can someone please calculate for me what's the value of Kb? 1.0 times 10 to the power of -14 over this value. What's the value, guys?
5.68 times 10 power of -10.
10. Alright.
10.
Thank you. Okay, alright, so you simply just multiply this value and then you square root everything to get the value of OH minus. Okay, so what will be the value for the concentration?
1.69 times 10 power of -5.
-5. Okay, alright, so this is the concentration of OH minus. So next you will need to calculate the POH, the negative log of the concentration of OH minus. Okay, you will get the value, and then last but not least, What will be the POH, guys? How about the POH? What's the value?
4.77.
4.77. Okay, 4.77. That means the pH will be 14 minus 4.77. Okay, apa tu ke 9 ni? Okay. Right, so this is roughly the steps that need to be taken in order to solve this type of problem involving salt hydrolysis. Okay, right. So this is the one, the answer scheme. Okay, so we have this salt dissociation, salt hydrolysis. You have to find out the Kb and then you find out the OH minus. So this will be the value. Okay, pH is this. Tada, solution is CH3COOK. Don't forget, okay, to finally conclude that CH3COOK solution is basic. Okay. Okay, there's one thing that I would like to draw your attention to. Kat sini lupa saya nak highlight on this one. Maybe sebab ada last time seorang tanya on how we should apa nama tu, in terms of the pH punya value. Where is it? Dekat pH this one. Ni Okay, note that the number of places after the decimal point in the pH equals to the number of significant figures reported in the H3O plus concentration. Okay, remember you kan tak tahu kan berapa banyak decimal places yang you should prepare for the value of pH. So it depends on the significant figures of the concentration of H3O plus used in the question lah. Okay, so katakanlah mana okay, this is this one, the significant figures is 2, right? 1, 2. That means you can prepare the decimal places for your pH should be 2 as well. Okay, should be 2. So this is based on this note here lah. Memang pun normally pH bila kita record the pH, the pH instrument is able to record the value up until 2 decimal point. Tak ada lebih daripada 3 lah, unless it is very sensitive instrument. Okay, but normally it will be 2 decimal places only, right? Okay, so please take note on that. Don't just simply bunda. Okay, make sure you consider for the significant figure of the concentration first, okay? Moving on, where is it just now? Okay, so we have one more. Yes.
Yang checkpoint 7 tu jawapan dia betul ke tak?
Aduh, checkpoint 7 yang mana lah? Yang 2.96 ke? Alamak, tak check ke lagi? Tak check lagi. Okay. Okay, lupa. Nanti saya check balik Right. So we are here just now. Done. Okay, question number 2. Calculate the pH of 0.69 molar of this NH4Cl. Okay, given the Kb for NH3 is this. Okay, alright. So sama saja macam method just now. It's just that this time around we have the reaction. This salt is produced from the reaction of, kita nak predict lah, if we have acid and base, what will be the acid and what will be the base that can produce this salt. Okay, so we have weak base plus HCl. So this is strong acid, this is weak base. So it should be an acidic salt. Okay, so bila you predict it should be an acidic salt, that means later on during hydrolysis, you should be producing H3O+. And you will be needing the Ka, guys. You don't need the Kb. If you have Kb, you have to convert into Ka. Okay, and then you can calculate the pH directly. You don't have to go for POH. Okay, so that's the plan. Okay, so as you can see, Kb is given to you. You don't want this Kb. What you want is the Ka of NH4+. Because this is a conjugate acid of weak base. This is weak base. This is the conjugate acid of this base. Okay, alright. So similar to the previous question just now, method dia sama. It's just that now the acidic salt, just now the basic salt. Okay, right. So look at the question. Look at these are the answer. Okay, this is the answer for this question. So these are the steps that need to be taken in order to find out the pH. Okay, did you manage to get the pH is equal to 4.7? If you manage to get this, that means you punya cara tu betul lah. Okay, make sure that you have these two. Okay guys, jangan sibuk nak calculate dia punya value saja. Ini markah, ini markah. Ini pun markah, ini markah. Okay, markah. Okay, any question related to salt hydrolysis before we proceed to 3.5 acid-base titration and indicators? Anyone?
Madam,
Yes.
kalau untuk calculation tu kan yang ice table tu, kalau tak buat, dia kena tolak markah ke?
Tak. Okay, sebab kita ada dua option, whether to use ice or the alternative method. Even sebenarnya tadi pun saya buat je ice table tu. Okay, tapi saya proceed dekat bawah tu guna alternative method. Bila you nak guna ice table, sebenarnya you tak pakai formula at all. Tu baru nama ice table. Maksudnya you pakai masuk dalam KA punya expression. Okay, and then find out the X. X is equal to H2O plus. Those is what we call ice method. Saya pakai je ice table tadi supaya saya nak nampak everything kan, clear kan. Itu ice table je. Tapi method-method bawah tu saya tak pakai pun KA expression. Okay, I straight away insert into the formula. Okay, in a way that is alternative method lah. Tapi kalau maybe you prefer not to have the ice table at all kan. So you macam ni, macam this one, we don't have ice table at all kan. So boleh juga. Tapi be careful. If the question specify the method that need to be used in order to find the pH, you kena gunalah that method. Normally the question would specify for alternative method. Dia tak cakap please use ice, jarang. Okay, we normally ask student, okay, we want the student to use this alternative method. So we have to specify in the question, please use the alternative method ataupun the simplifying method in order to find the pH of the salt, for example. Okay, kalau dia tak specify, you have the freedom to choose whether to choose the ice method ataupun the formula, the alternative method. Okay, right. Any other question before we proceed?
Yang salt dissolution tu kan?
Sorry, tak dengar.
Yang equation untuk salt dissociation tu kan dia dalam aqueous, so kita tak payah letak dia H2O lah kan yang dekat arrow.
Tak payah. Tapi kalau you nak go for the solid, kan dia ada dua option kan. You may use the solid. If you are using the solid for the salt, that means you have arrow, you have to place in the water on top of the salt ataupun below the salt lah. Okay, so dia ada dua option. So I rather use the aqueous lah sebab dia kita assume dia dah dissolve kan. It need to be dissolved in water in order to show the characteristic whether it is acidic, basic or neutral. Okay, so it is understood kat situ. So saya lagi prefer guna aqueous terus. Tapi if you are using solid, you have to have water dekat situ. If you don't have water, salah lah. Maksudnya reaction tu berlaku dalam keadaan solid. Tak boleh, dia kena ada water. Okay? So that's why my personal preference, I would go for aqueous. The garam itself and the ions all are in aqueous state. Tapi ni preference. Kalau you prefer nak go for solid, don't forget to have the water dekat arrow tu. Itu saja. Okay? Alright, lagi?
Okay, madam.
Okay.
Tak ada kot.
Ada Tadi macam ada dengar ni. Okay, tak apa. Alright, so let's proceed. Okay, acid-base titration and indicators, guys. Kita almost at the end of topic 3, tapi this is quite critical. This is very important subtopic. Okay, 3.5 acid-base titration and indicators. So this is the application, guys. Okay, application of acid and base. Okay, where acid and base is reacted together, okay, in a process that is known as neutralization ataupun reaction of neutralization, and the technique used is titration. So when we talk about titration, okay, you should bear in mind that you have burette, okay, you have burette, you have retort stand, and also you have conical flask at the bottom, and also pH meter. Okay, so pH meter, pH meter is not wajib lah, okay, but if you want to record, to track the pH, how it is from initial increasing, is it decreasing good, increasing, okay, and then after a certain point they reach to sudden increase, so those kind of thing you would need a pH meter, okay, for you to record or for you to track down the pH, the change in pH, okay, from the initial until the end. If not, what you need is just an indicator, okay, so based just based on the change of the color of the solution. Okay, all right, so like I said, this is the application. Okay, let's kita start from the beginning. Okay, at first we have acid and base separately, guys, individual. Okay, so we learn on how to calculate the pH of the acid, calculate pH of the base, and pOH and whatnot lah, to calculate the concentration and whatnot. So they are all in separate ataupun individual form. Kita belum campurkan dia lagi kan, belum lagi. Okay, kita separatekan dia. Okay, acid, macam mana nak kira, and then we have base, acid and base lah at the same time. Okay, acid and then base. And then we have salt. After acid, base, we learn about salt. Okay, all right, so salt, we know that salt, I've mentioned to you yesterday, salt is formed, okay, can be formed lah, okay, can be formed from the reaction of acid and base. Okay, and salt has its own pH. Okay, so tapi so far yang kita belajar adalah salt tu kita stand alone, individual. Okay, you are given the salt, you have to determine the pH. You belum diberikan, you bagi acid, base, and then you have to determine the pH of the solution. Belum lagi, that is 3.5 ni. Okay, so that's why kita punya kronologi cerita kita, acid, base, salt, semuanya asing-asing. Now kita nak combine everything in this subtopic, acid-base titration and indicators. Okay, alright, so for this one, the learning objective, make sure that you are able to draw and label the titration curve for the reaction between strong acid and strong base, strong acid and weak base, strong base and weak acid and weak base. So it depends on the pairing of the acid and base lah. It can be paired strong and weak, strong and strong, weak and weak, kan? So it doesn't matter. Okay, so make sure that you know how to draw the titration curve. Okay, then calculate the pH at the equivalent point. You kalau deal dengan acid base, you must know how to calculate the pH at the end of the day. Okay, alright, so we have a point that is known as equivalent point. On the titration curve, dia ada graph tu nanti. Alhamdulillah. Okay, we have a point that is known as equivalent point. So at this point, we have a pH that you need to calculate, okay, in order to determine this equivalent point, okay, for a given acid and base reaction. So this is very important. This is quite famous question lah. boleh kata 90% will be coming out in exam for the equivalent point. Okay, for the equivalent point. Now you have to know how to select the suitable indicators in acid-base titration. Tak all the time acid phenolphthalein saja. Okay, we have a lot of other indicators that can be used in acid-base titration. So how do you select your indicators? Okay, right. So these are the learning objectives for this subtopic. Okay, so like I said, this is how it looks like, the titration setup. Okay, you have a retort stand, you have a burette, and then you have a conical flask. Okay, so in the burette, you may place the base or the acid. If you place in the base in the burette, that means you should be placing the acid in the conical flask. Okay, and vice versa. Kalau you place in the acid in the burette, that means down here you should be putting in the ke atas asid bawah base lah. Okay, dia tak boleh atas asid bawah asid. Dia kena salah satu tu mesti dia mesti dua-dua berbeza lah. Okay, alright. So this is the stopcock where you control the movement of the solution in burette. Okay, we can control the movement of the solution by having the stopcock. Okay, this is volumetric analysis. Volumetric means you will be based on the volume, and then you analyze based on the volume that you required. Okay, let's say you masukkan this and you masukkan acid lah as in the conical flask. So up here will be the burette kan. Okay. Alright, so you nak tahu how much it is needed to fully neutralize all the acid here. Okay, alright, so you will start titrating, and then based on the amount of base needed to neutralize all the acid. Okay, you will have the volume needed for the base to fully neutralize the acid. And then later, untuk calculation, you will need to calculate the molarity. So what you will be having at first, maksudnya at first you will have the volume lah. Then from the volume you can convert into molarity later on. Okay, by using stoichiometry lah, acid base. Okay, so you boleh cari dia punya molarity. Then later kita boleh nak cari pH. Okay, alright. In an acid-base titration, the concentration of an acid or a base is determined by neutralizing the acid or base with a solution of base or acid of known concentration. You jangan baca dulu dalam kurungan. You baca yang without the kurungan. Okay, so let's read the statement again. In an acid-base titration, the concentration of an acid is determined by neutralizing the acid with a solution of base of known concentration. Okay, alright. Maksudnya kita kan pakai, like I said just now, we are going to be using the stoichiometry. Okay, kalau kita tak tahu the concentration of the acid here, we don't know the concentration of the acid. Okay, later we can calculate, because bila kita nak determine the concentration of the acid or base ke, okay, salah satu solution tu mesti known value. We know everything about the other solution, while the one that is unknown itu tak apa, itu kita nak cari, tapi yang lagi satu tu kita mesti tahu information on that solution. Then baru kita boleh link using stoichiometry. We have a balance equation, and then we have stoichiometry, and then we can relate from there. Okay, so that's why they kata the concentration of an acid is determined by neutralizing the acid with a solution of base of known concentration. Okay, of known concentration. Okay, this is by using stoichiometry lah. Okay, so set of titration and its titration curve. Okay, so this is how your titration curve looks like. Some correction has been made to this statement. Okay guys, please check and do correct your statement, okay, in your lecture notes. An acid-base titration curve is a plot of the pH of solution of acid or base against the titrant added. Titrant is the one that being placed in the, what do you call that, in the burette. Rasanya ni lain dengan awak punya dekat dalam lecture note. Okay, so please replace those dengan this one. Okay, right. So make sure everybody please take note on this. Please replace the one that you have in your lecture note with this titrant added, the solution in the burette. When we talk about titrant, that means it is a solution in the burette. Okay, all right. So titration curve is a plot of the pH maksudnya. So this is your titration curve kan. This is how your titration curve look like roughly. So we have pH versus the volume of the titrant added. Yang kita titikkan sikit-sikit tu. Okay, the volume of titrant added. So this is your burette kan. So this would be your flask. So katakanlah base in the burette, we place in the base in the burette. So down here we have acid. Okay, alright. So how do we predict ataupun roughly lah, how do we sketch? Okay, how should we sketch the titration curve? So this is how it looks like. Okay, alright. Remember, kenapa dia macam ni? And this one dia macam ni pula. Dia start. This one the zero. Okay, so this is 0 pH and 0 titrant added. Maksudnya at the beginning of the reaction. Initial lah, initial volume. Maksudnya before the titrant is added. Okay, you kena imagine bila buat reaction. Kalau you pakai pH meter lah kan. No. If you are using pH meter, you would be placing the pH meter. Alamak. Kecil benar dia punya gambar dia. No. Okay. So assume this is your pH meter. Okay. So you have acid in there, in the conical flask. So you place the pH meter down in the conical flask. You don't place the pH meter in the burette. Kan susah kan nak place the pH meter in the burette. So you place the pH meter in the conical flask. So the pH punya value, the initial pH which is around here, maksudnya before the titrant is added, before the solution from the burette is added into the flask. So this is the point dia ni, maksudnya 0. Okay, pH dia dah ada pH nampak ni, 0, dia dekat atas 0 ni. Yalah, because it is an acid kan, it is predictable. So this graph, okay, is obtained when you have the acid in the flask. Dia akan start daripada bawah ke atas. But if you have base in the flask, guys, if you have base in the flask and acid in the burette, again, you punya, what do we call that? You punya pH meter, okay, you letak dekat dalam conical flask. So since conical flask you ada base, that's why at 0 volume, maksudnya before the titrant is added, before the solution in the burette is added, the pH is already 14. I mean, the pH is already basic. Kenapa dia basic? From the beginning pun. Because it is based on whatever solution that you place in the flask. Duduk dekat bawah. Faham? So this is very important. So you have to determine which one is placed at the bottom and which one is placed in the burette. Sebab it will determine you punya bentuk graf you tu. You akan start daripada atas ke, you start daripada bawah. Okay, kalau acid, you akan start daripada bawah. This is the initial pH of the acid. Maksudnya before the titration starts. Okay, ataupun initial pH of the acid. That means we only have acid in it. So this is the part. And then kita akan start titrating, okay? Kita akan start titrating, start titrating. I mean, we start to add the titrant into the solution. Okay, alright. So what will happen is that, of course lah, when the acid is added, when the base is added. So this is first scenario, this is second scenario, okay? So when the titrant is added, which is the base is added into the solution, dia war lah, war tau, perang. Okay? So acid dengan base ni is totally two different characteristic. Karakter dia memang totally different. So when base is added into the solution, as if macam dia masuk dalam kubu acid. So acid ni takkanlah dia tengok aja kan orang serang tempat dia kan. So dia akan bawa bala tentera dia akan okay, excited. Okay, sorry. So base masuk dalam acid. Okay. So acid, okay, will serang the base. Serang as in it will neutralize the base. Okay, it will neutralize the base. Sebab before the equivalent point, kat kawasan ni, the mole of acid is larger than the mole of base added. Okay, alright. Tapi bila dia dah serang, maksudnya bala tentera acid tu dah yang bila dia serang, that means dia terkorban lah sebab dia neutralizekan the base just now, base added. So they sacrifice itself in order to neutralize the base. So what will happen is that the mole of acid started to decrease. Bila mole acid semakin berkurang, what happened to the pH? pH started to increase. Betul tak? That's why nampak dia ke atas sikit. Nampak? Dia going up. The pH dia start to increase. Okay, gradually. Yes, that's the word. Okay, started to gradually increase until it reaches the equivalent point. So this is before equivalent point, okay? This is after equivalent point. Once they pass this one, after equivalent point. Okay, azan kat tempat saya. Kita stop sekejap and we will continue after this, okay? Right, so let's continue. Okay, all right, so yes, okay, so this is the equivalent point. We will look at what is equivalent point later on. So this is basically the titration curve that you should know, especially on how to sketch the titration curve when you are asked to do so. Okay, all right. So like I said, it depends on whoever are placed on the burette, and then siapa yang kita place on the in the flask. Okay, right. So nampak tak? These two, dia punya starting point are different. Okay. So equivalent point, the term equivalent point. What is equivalent point? Okay, so the word you may familiar with equal. Okay, the root word of equal, that means we are talking about something that is equal in terms of the number of mole. Okay, so it's a point when the number of mole of OH minus added equals to the number of mole of H3O plus originally present, or vice versa. Okay, all right, so equivalent point is a point when the mole of acid is the same as the mole of base. We are talking about mole, okay guys? We are not talking about concentration, we are talking about mole. Because when we are talking about mole, it actually represents the molecule itself. When we are talking about concentration, kita ada factor volume dekat situ. Okay, concentration is mole over volume. When the volume change, the concentration will also change. Okay, so that's why we use mole instead, because mole represent kita boleh kata dia boleh represent the actual of molecule reacting. Okay, alright, so equivalent point is when the mole of acid is equal to mole of base. So we know that acid can be represented as H3O plus and base can be represented using OH minus. Okay, so pada ketika ini namanya point ni. Pada point ini adalah di mana mole acid sama dengan mole base. Tidak ada sedikit terlebih atau terkurang. Dia mesti exactly the same as what we have on the titration curve here. So this is the point. Dia bukan, kita boleh tahu range lah. Tapi setiap acid base titration tu has its own equivalent point. Specific equivalent point. Okay, all right. For example, strong acid and strong base, the equivalent point will be 7. Okay, equivalent point is equal to 7. Okay, at equivalent point, what actually happened at equivalent point? Okay, so kita tahu at equivalent point, this is the syarat. The mole acid is equal to mole base. Ingat perang yang saya cakap tadi? Okay. Base masuk, acid perang, acid neutralize kan. So makin lama acid makin kurang, dia punya tentera makin kurang sebab mole, so si base ni masuk kan, seorang masuk. So base keep on neutralizing the, saya cakap acid ke base ni. Kita ada acid in the conical flask, base in the burette. So when base is keep added into the acid, so the acid will neutralize the added base. Okay, so at the same time, bila banyak yang maksudnya mole acid tu digunakan untuk neutralizekan the base, so the mole of acid will start to decrease. Okay, maksudnya dia acid punya molecule tu dah makin berkurang. Okay, and then it reached to a point where all the acid is now habis, and same goes to base. Base pun they are all the acid and all the base have been fully neutralized. So there's no acid, there's no base in the solution. So that is what we call the equivalent point. And don't forget, the moment they neutralize, it will produce salt. Okay, so it will produce salt. Good. They neutralize the base, it will produce salt. Neutralize the base, produce salt. So at equivalent point, there's no acid, there's no base, but what we have is only the salt. So the pH at that time at equivalent point is actually the pH of the salt. Okay, ini yang application of salt hydrolysis yang you baru belajar yesterday. At equivalent point, okay, where there's no acid, there's no base because all of them have been neutralized and we have only the salt. Therefore, the pH at equivalent point is equal to the pH of the salt. Okay, so the equivalent point with the equivalent points, like I said, it usually only has one pH value only. It is very specific. That maksud, you imagine lah, mole acid can exactly the same as mole base. So the value should be one value only. Okay. Alright, so the end point is when the indicator changes color. So you must make sure that you are able to differentiate between equivalent point and end point. Okay, end point is when you use indicator. Okay, you are based on the change of color of the indicator. The indicator should be selected so that its color change occurs at pH close to that of the equivalent point. So you masa nak pilih the indicator tu pun kena pilih betul-betul. What we want is to track down the equivalent point. So we use indicator to help us do that. Okay, so in order to identify the equivalent point, kita kena pilih indikator yang dekat-dekat dengan equivalent point. Bila nak reach equivalent point, dia change color. Kita tak nak miss the equivalent point. Okay, so that's why we have this endpoint. Tapi the thing about endpoint ni, dia based on color. So some of us mungkin nampak color tu dah berubah, some of us may not see any changes yet. So itu yang ada error sikit tu. Okay, tapi it allow us to predict when to stop titrating. Okay, kalau tak, you imagine kita tak letak indikator. Berjanggut tunggu nak bila nak stop titration ni. Okay, sebab kita tak ada based on color ke apa kan, kita keep on titrating sampai bila nak titrate. That's why we need to have this indicator. So it gives us the endpoint. Okay, so the endpoint is when the indicator changes color. Okay, so this endpoint is in the range of pH at steep portion of the titration curve. Steep portion, like I said, this is the steep portion, guys. So this steep portion, steep adalah curam. Okay, pot paling curam sekali dekat titration curve tu, the curamest. Okay, macam saya cakap dekat S13 just now, the most curamest part in the titration curve. Okay, adalah bahagian sini. So kita kena find out dia punya pH range dia daripada sini. Okay, this pH range to till here. So kita kena find out indicators yang change color at this pH range. Okay, it's okay. This one kita akan tengok later lah on the topic of indicator. Okay.
Tapi kenapa curve tu dia mula tu naik slow, lepas tu tiba-tiba naik tinggi-tinggi tu.
Yelah. Dekat sini kan, suddenly kan. Macam ni kan.
Lepas tu bila dah sampai atas tu dia mula landai balik.
You kena imagine. Okay, you kena imagine dekat sini kita ada acid sahaja. Sebab bawah ni acid kan. Acid sahaja. And then starting from here, kita dah berperang dekat situ. Tapi mole of acid, okay, kat kawasan ni, mole of acid is still larger than mole of base. Okay, alright. So acid tu hantarlah bala tentera dia untuk perang dengan base yang dimasukkan. Okay, so as you can see, dia punya pH is increase gradually. Sebab apa? The mole of acid, dia pergi berperang tu, dia hantar orang-orang dia untuk perang tu. Okay, dia dah start berkurang. Sebab dia, the acid is used to neutralize the base. So bila acid punya mol berkurang, okay, what happen to the pH? pH will goes up. Betul tak? Dia kan inversely proportional. Okay, pH akan naik. Maksudnya acid punya concentration is decreasing. So what happen to the pH? pH will increase. Okay, dia kan inversely proportional. Okay, and then kawasan sini, the equivalent point is when mole acid is the same as mole base. Ini di mana acid dah habis. There's no acid anymore. And base yang kita masukkan tu pun kebetulan sama dengan mole acid in the solution. Okay, alright, so this is the point. Okay, kita keep on titrating sebab we have burette kan, we have the solution in the burette. So kita keep on titrating, kita keep adding the base. So that is why dia menaik dekat sini. Because you tak stop lagi reaction tu, you nak tengok what happen next kan. After you have reached the equivalent point, you still titrate the solution, maksudnya you keep adding the base into the solution. So what will happen? Of course lah, pH akan menaik kan, because at this point, kawasan ni, mole of base, of course lah, dia paling banyak daripada acid. Acid dah habis sebenarnya, so we only have the base only. Okay, mole of acid. Acid dah habis sebenarnya. Once they reach the equivalent point, mole dah habis. And then at one point, there's no increment in pH anymore. So pada ketika itu, yang pH yang you ada adalah the pH of base. And the garam lah. Because the moment dia neutralize, so garam tu dia still remain je kan dekat dalam tu kan. So dekat sini, dia dah start producing garam. So here dah tak ada acid. There's no acid anymore. So the garam is still here in this solution. Okay. So that's why dia punya graph dia tu, dia naik. And then at this point, dia naik secara mendadak. Sangat, dia steep, very steep. Kenapa? Sebab at this point, the mole of acid, dia kan specific value. Mole of acid need to be the same as mole base. Normally, kita tend to skip this equivalent point. Sebab, you imagine macam mana nak samakan mole of acid dengan mole base tu. It will be very difficult. Okay, you have to really calculate everything. You have to prepare everything. You have to determine everything, and so that you can predict dekat mana the equivalent point. You imagine you terlebih satu drop yang you rasa macam satu drop tu sikit. You rasa. Okay, tapi satu drop tu sebenarnya dah berlebih. Okay, sebab you based on satu drop, kita kena be specific. Satu drop tu is equal to berapa mole sebenarnya. Sebab it need to be the same. This mole of acid should be the same as mole of base. So at this point, we only have salt sahaja. Okay, here the mole of acid, mole base ni kita ada acid lebih, so base tu will be fully neutralized and salt. This one kita ada base and salt. Salt tu the moment dia neutralize, it will be there forever lah selagi kita tak interrupt the solution. Okay, so that's why you nampak dia punya curve tu increasing and then dia steep terus curam naik dekat situ sebab at that point dia the mole of acid tu kena exactly the same as mole of base. Tak boleh kurang, tak boleh lebih. Tu yang dia steep tu. Dia macam jump. Okay, dia bukan gradually macam tu. Right. Okay, so sebenarnya cerita tu saya tak perlu ceritakan pada ketika itu. Okay, tapi again, lah Madam awak ni suka extra, dia suka cerita awal-awal so that later you have the idea already and then when we go through the slides, cerita lagi, you dapat lagi idea. Bukan dapat idea, I mean when you know, bila kita cerita banyak kali, kita tend to apa nama tu, nampak things clearly lah. Okay, that's the plan lah. Somehow kadang-kadang tak nampak juga kan. Itu dia kena termenung, kejap fikir. Okay, saya suka imagine this acid base ni macam perang. Okay, you kena imagine, okay, the moment they add dalam flask, dalam tu ada acid. Acid nampak je, weh, kau buat apa kat tempat aku ni? Pak, neutralize. Okay, neutralize. So dia sendiri harakiri harakiri pergi neutralizekan. So terkorbanlah seorang asid, but at the same time terjagalah kubu dia. Okay, and then comes another group of base. Dan group of acid ni nampak. So everybody pun neutralize kan. Maksudnya they neutralize the base added. So at the same time makin lama acid semakin berkurang. The moment dia neutralize it will produce salt. Okay, alright. So this is for strong acid versus strong base titration. The initial pH is low. So this is the initial pH of the acid. That means before the added base. Again, the base is added. So ini kita boleh imagine dalam flask is the acid. Sebab apa? Sebab kita tahu dia start from the bottom going up. Okay. So kita boleh tahu bila kita letak pH meter yang measured dekat bawah ni adalah acid because they start from the bottom 1 macam tu. Okay, so the pH increases gradually when excess base has been added. So bila kita letak banyak base, definitely it will increase. It will increase lah. So nampak tak? This is gradually increases. Okay, gradually. Okay, so the pH rises very rapidly at the equivalent point, which occur at pH is equal to 7. This is strong acid versus strong base. Okay, this is pH at equivalent point. So these two are the common indicators used for strong acid and strong base. Okay, we can use phenolphthalein, we can use methyl rate. Like I said, if you nak choose indicator yang sesuai, you kena based on this steep portion. Range dia berapa? Okay, katakanlah, sorry, this one. Okay, this steep portion, range dia dalam 10. This one we have like 4 to 10 punya range. So you kena find indicator that it is, the pKa is this range. So normally we have methyl rate and phenolphthalein. Okay, alright. So this is the part where we only have hydrochloric acid sahaja. Okay, yang ni initial, imagine initial we only have the acid, and then after a while we start to have the this is this is Cl nampak Cl, and then water of course kita ada, and then kita dah start ada sodium plus dekat dalam tu. Okay, kita dah start ada base dekat dalam tu, and same goes to this one. So base dah semakin banyak dekat situ, excess. Okay, and then at this point, okay, at this point where we have excess in base, okay, we don't have the acid anymore in here. Okay, we don't have the acid anymore. Kenapa ada Cl minus kat sini ya? I believe this is the garam lah. Okay, sodium and the chloride. So this is Cl. Okay. Dia tak explain pula kenapa Right. So ni once the equivalent point has been reached, there's no acid anymore in the solution. There's no acid anymore. So because all the acid has been neutralized. Okay. Right. So this is these are the titration curve. Like I said, not to worry about this. What you need to be aware of siapa yang duduk dekat dalam flask, siapa yang duduk dekat sebagai titrant. So in this case, since they start from the bottom, so this is the characteristic of titration curve of strong acid versus strong base. Okay, so the equivalent point is pH is equal to 7. But the one that is placed in the flask, sorry buruk saya punya drawing saya, is the acid. Here we have base. Okay, alright. So if we have weak base versus strong acid, so kita nampak dekat sini kan, weak base they start at 0 before any of the titrant is added. The pH is already at 11. That means dalam flask is the base. We have base. Okay, dekat dalam burette we have acid. Okay, so weak base, as you can see, dia start from 11. Kalau strong base, dia 14 something, 13 to 14. So weak base normally 11, okay, 11 something. So dia akan neutralize the acid added. So this is the equivalent point. Okay, remember equivalent point is when we have only the salt, garam saja. So kalau strong acid dengan weak base, kita predict garam dia would be acidic, right? Okay, kita predict garam dia acidic. Betul yang kita dah belajar salt hydrolysis. See, the pH is less than 7, which is around 5 to 6 macam tu, 5 to 6. Nah, inilah masanya untuk you apply ni, equivalent point yang you belajar salt hydrolysis tadi. Okay, alright, and then if you have weak acid versus strong base. Okay, you tengok graf ni. Graf ni dia start daripada bawah. That means in the burette, in the conical flask, we have acid. Okay, we have weak acid, guys. This one we have weak base. This one we have weak acid. Kenapa? Nampak tak pH? Kalau weak base, dia 3 something. 2 to 3 something. So, weak acid. Okay, alright. So, in the burette, we have strong base. So, kalau strong base react with weak acid, okay, at equivalent point, that means we will have only the salt kan. So, the salt, the pH of the salt will be basic. So this is the pH of the salt, which is more than 7. So around 8 to 9 macam tu. Okay, around 8 to 9 dia punya equivalent point. So this is to be calculated later lah, subjected to the concentration of the acid and base given to us. Okay, alright, weak base dengan weak acid, yang ni yang agak ni sikit lah, but not to worry about this. This will not be coming out in exam. Okay, so dia punya graph macam ni. Okay, so this one, since it start from the top, so kita boleh tahu that the base is in the flask, the weak base, and the acid is placed in the burette. Okay, alright. So this 1, 2, 3 is very important, okay. Tapi yang paling important adalah for you to determine which one is being placed in the flask, siapa yang jadi titrant. Okay, right.
Madam, yang belakang tadi slide sebelum ni, yang nombor 2 tu, lepas ni, yang graf. Graf. Yang nombor 2 tu dia bukan strong base ke madam? Dalam conical flask.
Strong base. Weak base. Weak base sebab dia 11 something, normally dia weak base. Kalau dia strong base, normally dia 13 to 14 dia punya pH of strong base.
Oh, okay.
Okay. So ni lah. Mana kita tak ada contoh kat sini kan.
Itu ada yang bulat putus-putus tu, apa benda sebenarnya?
Bulat putus-putus?
Yang dekat sebelum ni, ya. Contoh yang ni, slide sebelum ni. Yang tu kalau ada bulat putus-putus.
Ni, bulat putus-putus. Mana putus-putus?
Contoh yang kat gambar tu. Kan ada macam bentuk bulatan, lepas tu dia putus-putus.
Oh ni. Sekejap, tak nampak dah. This one. Kenapa?
Itu.
Apa dia bulat putus-putus di situ ada satu pula tu ke dia nak tunjuk this indicators?
Tak boleh ingatkan tunjuk
kat sini kot.
Gambar tu. Tapi bila tengok tak, dia bukan menunjuk ke situ.
Mungkin dia nak highlight on this one. The pH rises very rapidly at the equivalent point. Maksudnya dekat sini, okay, dia dah tak ada point dah, nampak tak? Dah tak ada point dot ni, dah tak ada dah. Because at this point, from here to here, okay, is the critical point di mana dia nak reach the equivalent point. Okay, so any additional drop will cause, kalau dia tak equal, it will cause the pH to be increase rapidly. Okay, kalau kita buat lab, selalunya student dia akan miss out this pH is equal to 7. Dia mesti terlangkau lebih sikit, 7.5, 7.6, dia terlebih. Okay, sebab dia ada this value 4 something and then suddenly dia jump to 7 something ataupun 8. Kalau even worse, dia dapat terus 10. Sebab susah tau nak dapatkan dia exactly the same. Sebab you tak tahu dia satu drop tu is equivalent to berapa banyak mol. Okay, so that's why dekat sini is very critical. You ada this part, pH is equal to 4 for example, then suddenly dia jump to pH is equal to 10. So this is rises very rapidly at the equivalent point. So from here, terus, kalau you lucky you got the 7. Normally you will exceed the 7 lah. Okay, maybe this is to highlight the rise of the pH, drastic rise in pH. Okay, that's why dia bulat kat situ. Dia bulat dekat sini. Kat sini dah tak ada apa-apa dah. Sebab once you terlebih, you akan jump into here. Okay. Right. Yeah. Alright. So ni nak masuk calculation ni. Ini yang betul-betul ni. Ni yang serius, yang stress kita. Okay. For a general acid-base reaction, so I'm sure that you are very familiar with this formula, guys. MAVA over MBVB is equal to A over B. So this is normally used for acid-base reaction. Do you know when we use this formula, it means that we are calculating at equivalent point. Tak tahu, sekarang tahu kan? Okay. This is used because we want to know how much of the acid is needed in order to neutralize all the base. Okay, so this is stoichiometry lah. Okay, this is stoichiometry. So we use this formula to represent the volume, the molarity needed at equivalent point. So this formula is calculated at equivalent point sebenarnya. Maksudnya kita nak tahu the volume, how much is needed, the molarity. Okay, from the molarity we will be able to know the mole and so on. Okay, so as you can see kita ada M, V kan, A, B can be obtained from the equation. Okay, alright, so this is at equivalent. Okay, exactly, look at the example. Exactly 21 ml of 0.1 molar sodium hydroxide solution was required to completely neutralize 20 ml of H2SO4 solution. See? Completely neutralize of H2SO4 solution. Calculate the concentration of the acid. Walaupun dia tak cakap yang dekat pada ketika ini ada salt saja, no, dia tak mention. Tapi you should, since you have learned it just now, okay, completely neutralize, that mean when everything is totally neutralized, that means we only have salt. We don't have any of the acid or base in the solution. What we have is only the salt and water. Okay, so ini rasanya you don't have problem in terms of nak gunakan MAVA and BVB. If you want to use this formula, you must have equation because this A over B is extracted from equation. Okay, alright. Okay, kita nak start ya. Okay, sebab kita ada different set of acid-base titration. Kita ada strong lawan strong, weak lawan strong, strong lawan weak. Okay, again like I said, kita kena based on siapa duduk dekat bawah, siapa duduk dekat atas. Okay, let's start with strong acid versus strong base. Okay. Ready Bismillahirrahmanirrahim. Okay, sodium hydroxide reacted with HCl to produce H2O and the salt. Okay, so basically in this reaction, what actually happened is that OH will react with the H3O plus from the HCl to produce water. Okay, so this is the equation, and then this is the graph. This is the titration curve. So from the titration curve, we can predict that the one that will be placed, the one that are placed in the flask is the acid. Okay, yang dalam ni adalah base. Macam mana tahu? Because they start from the bottom going up. That means you boleh imagine bila you letak the pH meter tu, Okay, the initial will be the initial of the acid solution in the flask. That's why dia dekat sini initial dia. Okay, so you boleh predict terus, you boleh buat curve dia tu, you boleh sketch the curve, bentuk dia memang macam ni. Okay, and then since the strong acid versus strong base, it is predictable for the pH of the equivalent point to be at 7. Memang 7 lah, strong acid lawan strong base kan, it produce neutral salt. Okay, so at equivalent point, we only have the salt sahaja. So the pH of the salt will be 7. So this is the recorded value, guys. Proven that the value is 7. Okay, all right, in case, okay, so there are a few points that you should know because the question might ask the pH at this point. Okay, all right, so dia boleh tanya initial pH. Okay, all right, so it depends lah. Like I said, it depends. This is with subject to this graph. Graph dia daripada bawah ke atas. So kalau kita place in the base in the flask, how would the graph look like? Graph tu akan nampak macam ini. Ya, dia terbalik ya. This is pH. This is volume of acid lah. Volume of the titrant. Since the cut dalam flask is the base, so the titrant will be the acid. So you have to label. So this is the 7 equivalent. Saya punya ni equivalent point. Okay. Sebab this still strong acid versus strong base. It's just that you change the solution. Instead of you place in the acid in the flask, you place in the base. Okay. All right. So this one. This is the initial pH, but this is 0 kan, before any of the titrant is added. Okay, if the question asks for the initial pH for strong acid versus strong base titration, how would you calculate? Okay, how would you calculate? Ini macam mana you nak imagine dekat sini? So initial pH, that means the initial solution. So at initial, that means before the added, before the titrant is added, apa yang kita ada? Okay, kalau subject to this one, this graph, kita hanya ada acid sahaja in the solution, and it is strong acid. So how would you calculate the pH of strong acid? Remember, dia fully dissociate kan, strong acid fully dissociate in water. So kita boleh kata the initial concentration of strong acid is equal to the concentration of H3O+. Therefore, the pH is equal to negative log H3O+. Ini apa yang awak belajar masa yang awal-awal tu, kita nak apply in acid-base titration. So you kena imagine, okay, at this point of time, apa yang ada? We only have strong acid. So how do you calculate the pH of strong acid? Initial pH ni. Initial pH is the pH of the acid we subject to this one lah, this strong base acid titration. Okay, so kita tahu strong acid dia fully dissociate, right? So bila dia fully dissociate, it will produce the same amount of H3O+. Same amount of initial tadi sama dengan concentration of H3O+. Itu yang paling important. Same goes to base. Kalau base is placed in the beaker, scenario number 2, okay, initial pH would be the pH of the strong base. So we know that the concentration of OH minus will be the same as the concentration of the initial of the strong base. Sebab apa? Sebab dia fully dissociate. So you can simply use the value of the concentration of the base, okay, masukkan dalam POH tu, and then dapatkan the pH. Okay, so that's the plan lah. Ini plan dia. How about pH at equivalent point? So this is something yang you tak payah worried. Okay, there's no calculation involved because why? Based on our understanding, if we have strong acid versus strong base, the salt produced will be neutral. Neutral as in the concentration of OH minus and H3O plus remain the same. So bila you calculate the pH of this concentration, you will still get 7. That's why it is proven that dia adalah neutral. This is at equivalent point di mana kita hanya ada salt sahaja. Okay? Alright, so this is for strong acid versus strong base. Okay, let's look at an example. Calculate the pH of a solution in which 0.1 molar sodium hydroxide is added to 25 ml of 0.1 molar HCl. Saya macam tak faham soalan ni. Rasanya the pH at equivalent point kot. Calculate the pH of a solution in which 0.1 molar. Nak cari apa sebenarnya? The pH of the solution. Macam nak cari pH at equivalent point kan? Okay, calculate the pH of a solution in which 0.1 molar sodium hydroxide is added to 25 ml of 0.1 molar HCl. Okay, alright, so first you have to identify, okay, this is reaction between sodium hydroxide and HCl, strong acid versus strong base. Okay, so bear in mind prediction kita, the pH at equivalent point should be 7. So write the equation. So this will be the equation. So to reach equivalent point, the mole of sodium hydroxide should be the same as the mole of HCl. Okay, so it should be the same. Then only it will be fully neutralized. So kita kena find out the mole of HCl. Okay, because what is given to us is the mole of the volume and concentration of HCl. So from here we can find out the mole. So this is the mole of HCl. So bila kita tahu satu saja, automatically kita akan tahu for sodium hydroxide. Because why? At equivalent point, the mole of acid need to be the same as the mole of base. Okay, alright. So we have the mole of HCl. Initial, this is at initial, that means we only have HCl. So we don't have sodium hydroxide and sodium chloride. Okay, and then the added mole, later on, the added mole, kita tambahkan sodium hydroxide. And then kita start adding the sodium hydroxide. So how much mole will be added in order to reach the equivalent point? The same mole as the initial. Okay, banyak ni. So these two, HCl dengan sodium hydroxide, these two will be fully neutralized. That means there will be no HCl and there will be no sodium hydroxide. So that's why dia jadi the final mole is equal to 0. And we only have the garam. Okay, so we know that NaCl is a neutral salt, so they do not hydrolyze in water. Okay, kenapa? Sodium come from sodium hydroxide, chloride come from HCl. So both of them are very weak conjugate acid and conjugate base. They do not hydrolyze in water. Therefore, the pH will be the pH of water, which is 7. Okay? Alright. Done for strong acid versus strong base. Okay? Next, we have weak base versus strong acid. Yang ini yang quite famous in exam. Dia mesti bagi satu, normally in exam, okay, you will be given the weak and the strong. Kalau strong lawan strong, pH at equivalent point, nak tanya apa? Because the pH will always be 7. Okay, kalau weak lawan strong, kita boleh tanya the pH at equivalent point. Okay, so how would you calculate it? Okay. Any question, guys, before we move further? Any question related to strong acid and strong base just now? How would you want, how things need to be calculated ke anything? Any question related to that?
Clear, madam.
Clear, this is very critical, okay guys. Ini application, you kena betul-betul faham nak apply. Okay, right, kalau tak ada, saya move on to the next set of acid-base titration. We have weak base versus strong acid titration. Okay, so it can either be strong acid versus weak base, because yang paling important, you should know which of these two is placed in the conical flask. Okay, kalau based on this titration curve, the one that is placed in the conical flask is the base, weak base in the flask. Sebab dia from top to bottom. At initial, maksudnya before ACl is added, the pH is already high. That means the kat dalam flask tu is the weak base. Okay, is the weak base. Okay, let's just KIV this one first. Okay, kita KIV this one. This one is buffer sebenarnya. Okay, so kita akan KIV. We will come back to this. Please remind me, okay guys, about this. Once kita dah start buffer, I'll come back to this slide. Okay, alright. Example guys. Okay, example. Katakanlah, okay, contoh kalau the other way around, we have strong acid in the beaker and weak base in the burette. So how would the titration curve looks like? pH. This is volume of base lah. Okay, is it? Yeah, volume of base. Kita nak terbalik from this one. Okay, so you should be starting from the bottom, guys. Okay, you should be starting from the bottom. Sebab dia strong acid kan, so dia nak dekat-dekat, dia 1, 2 macam tu. 1 macam tu So around here lah. Strong acid around 1 macam tu. Dia dah start ni lah. Ni saya punya ni terpendek. Okay, kena panjang sikit. Tada! Okay, so this is your equivalent point. Okay, alright, so kita predict at equivalent point, the pH should be, this is strong acid versus weak base kan, so the pH should be less than 7. Okay, so katakanlah 7 dekat sini, so this is like 6 or 5 macam tu. Okay, alright, so let's clear everything. Semak. Okay, so example of a weak base versus strong acid, we have HCl reacted with NH3 to produce salt. Okay, alright, so we know that at equivalent point, these two will be totally fully neutralized. So we don't have these two anymore. We only have garam kan. So this will undergo dissociation and this one will undergo hydrolysis. This one will not be hydrolyzed. Ini kita tahu, kita dah belajar kat salt hydrolysis. Tapi you kena tahu ini berlaku pada equivalent point. Okay, alright. So macam mana nak calculate? Ada point-point yang soalan suka tanya. Satu dekat initial pH and one more thing dekat at equivalent point. Okay, alright. So not to worry about this one. Okay, ini dia punya like formula lah for you to remember. But what is most important is for you to understand, for you to be able to imagine what is actually happening in the reaction. So you imagine, like I said just now, untuk strong acid dengan strong acid and strong base just now kan. Initial pH, maksudnya before we start titrating, apa yang ada dalam flask. Kalau weak base yang ada dalam flask, you nak tahu the pH of weak base. Weak base, we are talking about weak base. So macam mana you nak tahu the pH of weak base? So you should be using this one kan? This formula. This is if you have weak base. Kalau you have weak acid, that means this one is no longer OH minus. This one should be H3O plus. This one should be Ka. This one should be acid. Okay, and then everything will be automatic lah. Yang like you automatic tahu next step you should you should be doing. Okay, so jangan risau sangat pasal formula-formula yang dia bagi ni. Yang penting you faham. Okay, pada ketika ini we only have the weak base. So how would you calculate the pH of weak base? Kan dah belajar awal-awal lah itu. Okay, ini bukan something yang you kena, something yang baru. Ini saja dia nak letak dekat situ for to guide you. Okay, kalau saya pun not so concerned on this formula lah, because I've learned that one before. Saya dah learn, okay, how do we calculate the pH of wheat base? Because at the beginning we only have wheat base saja. Okay, kita belum masukkan acid. Kan? So initial pH depends siapa, kalau wheat acid ataupun wheat base. Okay, pH at equivalent point. Okay. Okay, ini yang soalan famous. Lagi sekali, not to worry guys. Okay, pH at equivalent point, that means we only have salt. Okay, so tadi kita predict wheat base lawan strong acid. So kita predict that the salt should be acidic salt, right? So the pH should be less than 7. Okay, alright. So dekat sini, it should be acidic. That means you should be producing, bila you buat hydrolysis, you should be producing H3O+. Okay, and you will be needing the Ka. So this is the part yang you akan calculate. Tapi, one thing that you have to be careful is this one. Concentration. Ka times C kan, normally kan? Ka times C. Tapi C kat sini ada sikit changes. Ada slight changes dekat situ that you have to be careful. Okay? Sebab, okay, one thing, cuba kita bezakan. Last time, masa kita belajar individual acid and base tu, the concentration is already given to us. It's not given in terms of mole, it's given to us in terms of concentration. So we can just use the concentration, insert into the formula. But this time around, you can imagine, sebab titration berlaku. So ini katakanlah we have wheat base in the flask. And then titration berlaku kan. So you add in, katakanlah tadi dalam ni apa, base, wheat base. You add in acid. Okay, apa yang berubah dekat sini guys? Volume. Volume is now changing. Okay, yes, it is true that at the end of the day, we have to calculate the pH is equal to the log concentration of H3O+. So, since we keep adding the base ataupun titrant into the solution, the volume will definitely be changed. Betul tak? Volume berubah. Bila volume berubah, the concentration of H3O+, of course, will change as well. Okay, that means you have to consider bila you nak calculate the concentration of the yang C tu, yang last time C yang selalunya kita insert itu, you kena consider the total volume of the acid and total volume of the base so that you can get the new concentration. Faham? You kena dapatkan the new concentration. Sebab ingat, bila titration start, dia ada berlaku perubahan volume. Volume will affect the concentration. Okay, sebab kita nak the concentration of H3O+ later on. Since volume is now changed, of course the concentration of H3O+ will change. So we have to consider the volume of titrant added, not only the volume of the base yang memang ada dalam flask, the volume of the titrant added. Kita kena total up that volume so that we can get the new concentration. Itu je dia punya perubahan dia. And then once you get the concentration, the new concentration, you can insert into this formula. Okay? Alright. Sabar. This is another example. This is if weak acid versus strong base. Just now we have strong acid versus weak base. Okay? Alright. Example. This is weak acid versus strong base. This is the salt. So we predict the salt should be basic. Okay, it should be basic. That means the pH should be more than 7. If it's basic, you should be producing OH minus. That means you will be needing the Kb, and later on you will need to calculate the pOH and later the pH. Ini kita dah tahu. So hydrolysis just now. Okay, alright. So dia ada dua part yang normally will be asked in exam. Initial pH bukan masalah pun, you kena tahu siapa yang ada dalam flask. Okay, is it strong base ataupun weak acid? Kalau strong base yang ada dalam flask, you kena kira the pH based on strong base punya style. Kan dia fully dissociate, dia berbeza kan? Fully dissociate. Kalau weak acid is in the flask, that means you kena kira the pH based on weak acid punya style, which is using the formula. Okay? So, ni dia assume kalau dalam ini, kenapa dia bagi macam ni? Sebab dia assume dalam flask adalah weak acid. Sebab dia based on this one, this graph. Dalam flask ada weak acid sebab dia start from bottom going up. Okay? Alright. pH at equivalent point. Again, sama like I said, dia OH kan? So it will be basic, right? So you may need to use this one to find out the concentration of OH minus. But one thing that you have to be careful is normally the KB times C kan? C, this one. Concentration ni you kena prepare the new concentration. You cannot just simply use the initial concentration. No. That one before titrant is added. Bila titrant is added, volume is now different. Okay, so that's why you have to consider the new concentration in which the volume need to be total up. Okay, dah. Kalau you dah dapat volume ni, you dah dapat lah apa, I mean, you okay, not to worry about this guys. Okay, you may, you calculate for OH minus and then proceed to POH and then pH. Okay, this is another formula lah. If you want to calculate for H3O plus directly, you boleh calculate H3O plus directly. That means you have to KW over all of this. Okay, and then you calculate the H3O plus. Okay, so tak apa, kita pakai style lama OH, and then from OH kita calculate POH, and then 14 minus the POH. Done, settle. Okay. Okay, faham ke? Faham ke? Sebelum kita nak tengok contoh ni, kita try contoh tak payah. Tadi just like apa nama tu, apa orang kata macam the idea of it lah on how to solve problem related to weak versus strong acid base titration. Okay, so let's look at the example when it involves weak versus strong titration. Okay. Calculate the pH at equivalent point. pH at equivalent point ni memang very famous question. That's why saya kata 80% atau 80 to 90% will be coming out in exam. Okay, and usually it will involve the weak versus strong. So you should be prepared lah. Okay, calculate the pH at the equivalent point when 25 ml of 0.1 molar ammonia is titrated by 0.1 molar HCl solution, given the Ka of NH4 plus is 5.6 times 10 to the power of negative 10. Okay, so let's just be prepared, guys. Okay, we know that at equivalent point, all the acid and all the base will be fully neutralized. We don't have any of these two. So what we have, only the salt. We have the salt only in the solution. So the salt, this is between strong acid versus weak base. Okay, so the salt is predicted to be acidic. So bila you predict acidic salt, okay, macam biasa, you akan kena dapat H3O plus and you will be needing the Ka. Okay, since you dapat H3O plus, you can calculate the pH. Okay, alright. So Ka, the one that you need is Ka. So the Ka is given directly to you guys. Okay, bagus lah. So kita boleh pakai the Ka lah. Okay, the Ka of NH4 plus. Usually dia bagi Kb of NH3. Ni dia dah bagi Ka of NH4 plus. So kita dah boleh skip satu part yang kena darab dengan Kw tu. Divide by Kw. Okay, right. So it's given directly to us. Okay, just nice. Dia nak pH at equivalent point. Okay, for this volume of ammonia and concentration of HCl given. Okay, so this is the equation, guys. You kena ada equation. From this equation, you can see that it is a 1-to-1 ratio of acid and base. Okay, kena ada equation. And then from there, okay, kita nak nampak everything clearly. We would have this mole table. Ini kita panggil mole table. Okay, kita kena ada mole table. So nak ada mole table, kita kena tahulah mole of the substance in the flask. Okay, alright. So 25 ml ni normally the one that is placed in the flask. So we have 25 ml. So for this one we can calculate the mole. So what is the mole for this? This is the mole for the wheat base. This is the mole. Okay, you boleh simply calculate. So you dapat the mole of the wheat base. Okay, and then has the equation, guys. So this is the equation, right? Okay, so you nak tahu so this is only the wheat base. Okay, so you nakkan dia punya garam. You nak garam. Okay, so before you dapatkan the garam, you kena tahu berapa mole acid and berapa mole base dulu. So we have the mole of the base. Okay, so since we are talking about equivalent points, so the mole of acid should be the same as mole of base. So these two will be fully neutralized, so dia jadi 0, and then we are left with this amount ataupun this mole of acid, this mole of salt. Okay, this mole of salt. Nampak tak? Like I said last time, acid-base titration, acid-base reaction should also use one-headed arrow ataupun single arrow. Okay, the single arrow maksudnya it will not be reversible. Okay, alright. So this is the part that you determine the mole of the salt. So you dah ada this mole of the salt. Okay, you dah ada this mole of the salt. You boleh proceed dengan apa nama tu salt hydrolysis, salt dissociation and salt hydrolysis. Okay, salt dissociation and salt hydrolysis. Kalau saya tak buat ni dulu. Okay, saya akan proceed dengan salt dissociation and salt hydrolysis because we have this already. Kita dah ada mole. So saya pun nak proceed kepada sorry guys. Kena proceed to this volume. You have to find out the volume. Okay, sebab you kena remember the salt produced is due to the added titrant. Okay, dia neutralize kan, so dia akan produce the salt. So pada ketika itu salt tu volume dia tu dah berubah pada ketika itu. Okay, bila volume berubah, of course the concentration will also be changed. So the mission now is to find the volume. Okay, so we have the volume of the wheat base just now. The wheat base, the volume is 25 ml. Okay, so we have to use this formula in order to find the volume of the acid, strong acid. So you kena guna this one. So you still dapat 25 ml. And then you totalkan the volume, you got 50 ml. And then you find out the concentration of NH4Cl. So this is something that you have to do before you insert into the salt dissociation and salt hydrolysis punya step. Inilah tambahan step dia tu yang you kena prepare. Okay, sebab concentration is no longer the same because the volume is now changed. So you dah ada mole just now, right? You have the mole already, right? So you have to divide with the volume. So the total volume of the HCl and the wheat base is 50. Okay, so make sure you convert into liter. So this is the molarity of the salt. Dah ada ini, bolehlah teruskan hidup macam biasa yang kita buat salt hydrolysis sebelum ini. Okay, alright. So you kena ada this one, apa nama tu, salt dissociation. This is the salt dissociation. Okay, and then you have this salt hydrolysis. hydrolysis. You may use ice table or you may use the alternative method. Yes, sebab you kena produce H3O, you produce H3O plus kan. So this is the salt hydrolysis. Initially tadi kan kita dah dapat this is 0.05. Okay. So it will also produce 0.05 and 0.05 of this. So this will not be hydrolyzed, but this one will hydrolyze it. And then you proceed to salt hydrolysis. Nampak tak? Step dia sama je. Sama je dengan previously yang kita buat tu. Okay. Alright. So this is if you are using ice table, ice method. Okay. You masukkan dalam expression and then you find out the X and then the concentration of, the X is equal to concentration of H3O plus. And then you insert the value into pH and then you find out the final pH. Okay. Alternatively, ini cara panjang lah. Ini cara panjang if you are using the ice method. Alternatively, you may use this method. Okay, you may use this method. Senang aja masukkan je lah dalam formula tu yang mana you ada Ka is it? Ka times C. Yang C ni tadi kita dah prepare earlier tadi yang kita kena totalkan the volume. Okay, alright. This is H3O plus and then you teruslah cari the H2O plus and then find out the pH. Tada, siap. Okay, faham ke tak faham? Faham tak? Cuba tanya. Tak tahulah madam, saya pun tak faham. Saya pun tak faham apa yang saya tak faham. Okay? Soalan. Cepat.
H plus tadi tu sama dengan H3O plus ya?
Sama. So, kalau awak jumpa H plus, gantilah semua dengan H2O plus. Okay, ganti semua dengan H2O plus. Dia tak konsisten dekat dalam kita punya slide note. So, it should be H2O plus. Okay? Any other question? Lagi question? Yeah, so again, saya nak highlightkan dekat sini. This is the critical part that you have to prepare the concentration of the salt. You kena consider the total volume. Because why? Okay, sebab nak menjadi garam tu, acid dengan base, acid daripada kata titrant tu kena react daripada burette tu, kita kena dropkan a portion of it. Okay, kita reactkan these two, then only we will produce the garam. Okay, so in order to get the concentration of the salt, kita kena consider the volume, the new volume. Maksudnya volume taking into consideration the volume of the titrant that already been combined in the flask. Itu logiknya kenapa kita kena cari the new concentration. Sebab volume is now changing. Okay, volume is now changed. It's no longer the same macam sebelum kita masukkan apa tu? Masukkan titrant. Okay, alright. Guys, get that? Okay, cuba kita buat sama-sama on checkpoint 12 ni Jom kita buat sama-sama. Kena ni awak, ini kan saya dah kata confirm keluar. So kalau ini you tak dapat jawab, so you dah hilang 5 markah dah dekat situ confirm. Cuma tak tahulah soalan ni sebiji ke macam ni ke apa, tapi related to equivalent point. And then one more thing, initial pH. Something that you need to consider. Okay? Alright, so jom kita buat soalan ni. 25 ml of 0.1 molar sodium hydroxide react with 25 ml of 0.1 molar CH3COH. Okay, ini dia tak pakai, dia terus straightforward. Okay, we have 25 ml of sodium hydroxide, 25 ml of CH3COH, neutralize one another. Okay, and then you have to calculate the pH of solution at the equivalent point. The Ka is given. Okay, alright, so you have to calculate the pH of equivalent point. Okay, sodium hydroxide is strong base. This one is weak acid. Okay, we know that at equivalent point, we have only the salt. Okay, so it will produce the salt that is basic. Okay, that is basic. So salt dia basic. So bila basic dalam otak tu dah boleh imagine nanti you kena produce OH minus. That means you will be needing KB. And then later you nak kena calculate the POH and then later pH. So that's the plan. Okay guys. Alright. So okay. Saya kan, kalau saya punya style, saya macam ni. Saya tahu ini kita calculate for salt kan. So, I will straight away go for salt dissociation. And then from there, bila saya start, oh, ini nak cari concentration. Then only I go back to finding the volume. Okay, using the MAVA and BVB. Okay, so style saya macam tu lah. Okay, so kita dah tahu salt kan. Salt, it involves salt hydrolysis. So, let's start from the acid-base titration. Okay, the acid-base titration. So it is sodium hydroxide. Dia depends lah. You punya preference. You nak start macam mana tu. Dia depends pada you. Okay, sodium hydroxide. Since this is acid-base punya reaction, kita kena ada the equation. Satu arah ya. Acid-base. Kena ada single arrow. H3COONA plus H2O. Okay, alright. So this is the bila kita buat equation tu baru kita baca plan kan kat dalam otak kita ni. So we have this one. So we want to find the concentration of this. Okay, so what we have at the moment is this one. So we can find these two. Okay, alright, so we need to find the mole for sodium hydroxide and CH3COOH. Okay, so kita nak cari mole ni, macam nak cari mole ni, N is equal to NV, M is 0.1 molar, okay, mole per liter times 25 mil. 25 times 10 to the power of negative 3 liter. Okay, liter. Okay, berapa ya? Boleh tekan kalkulator? What's the value for that one? Okay, the mole is 2.5 times 10 to the power of negative 3 mole. Okay, so this is mole for sodium hydroxide. And how about mole of CH3COOH? It is the same. Kita pun calculate sama 0.1 mole. Sebenarnya once you dah nampak dia sama tu, you dah nampak exactly the same. So you boleh, it is 2.5 times 10 to the power of negative 3. Terus je. But after all ni equivalent point kan, it should be the same. To be able to fully neutralize one another, the mole should be the same. Okay, alright, so we have this mole. Right, when these two mole neutralize one another, so later dia akan equal to 0. Okay, so this is initial mole. Okay, which initially we don't have these two. Okay, after, okay, this is equal to 0 and this is also equal to 0. How about this one? They dah fully neutralized, it will produce the garam. Betul tak? How much garam will be produced? 2.5 times 10 to the power of negative 3 mole. There you go. So you dah ada the mole of the garam. Okay, due to this one, okay. So this single-headed arrow, so it means that it will fully neutralize and produce the same amount of mole for the salt. Right, so next, before we proceed to salt dissociation, for example, kan, so we have salt dissociation, CH3COONA, it will dissociate into CH3COO minus plus Na plus, right? Okay, so we need to have the concentration of this one. Sebelum nak proceed, we need to have the concentration of this one. Okay, but at the moment we only have the mole. So kita nak concentration. So apa concentration dia? Itu kita kena bersabar. Okay, so in order to find the concentration, the new concentration of CH3, COO, and A, that's why you kena totalkan the volume. The new concentration of CH3, COO, and A, okay, boleh tulis new lah. New concentration. Okay, is equal to 2.5 times 10 to the power of -3 mole ish divided by volume. So the volume of acid plus base kan. So we have 25 ml of acid plus 25 ml of base. Don't forget to convert into liter. Okay guys. Sorry, 25. Okay. Sorry. Okay, liter. Darab 10 kuasa -3 liter. So 2.5 exponent -3 divided by 50 exponent -3. So you should get 0.05 mole per liter, which is molar lah. Okay. There you go. So you dah ada lah concentration here. So once you have the concentration here, okay, so you have this molar. So when this one, dia dissociated fully in water, right? So it will fully dissociated. Later dia akan habis. It will produce this 0.05 molar of CH3CO minus and 0.05 molar of sodium plus. Since this one will not be hydrolyzed, so kita abaikan saja. Okay, so we are going to be using this part. Okay, nak conteng kat mana pula ni? Conteng kat atas ni. Okay, let's change to other color. Let's have green. Okay, alright. So this is the salt dissociation kan. So salt hydrolysis will be salt hydrolysis. Okay, CH3COO minus plus water reversible. Just now kita predicted that it should be basic, right? So you prepare OH minus siap-siap dekat situ. Is it basic? Yes. Okay, it should be basic. So this one should be CH3COOH. Okay, alright. So you may use ice table ataupun you may use the alternative method. Kalau you nak guna ice table saja nak just to have the ice table. Okay, initially just now kita dah ada 0.05. Okay, initially we don't have these two. After a while it changed. This is how much is changed. Okay, 0.05 minus x, x, x. Okay, alright. So next we want to find out the OH punya concentration lah. Okay, kita boleh insert into the formula right away. OH minus KB. So you need the KB guys. You need KB. Kita perlukan KB. So what is given to us is KA. Okay, alright. So not to worry, kita mesti mencari KA dulu. Kita tak boleh masukkan dia directly dalam ni. Boleh, tapi semak. Okay, ada student buat 1.0 and then divided by KA. Boleh juga, tapi buatlah kat tempat asing. Asingkan supaya when you get that value, you dapat 1 mark. Okay, kita takut kalau anything happen here, you salah, so everything will be wrong. Okay, so the KB is equal to KW times KA, right? So KB is equal to 1.0 times 10 to the power of -14 divided by KA 1.8 times 10 to the power of -5. Berapa? 0.0 exponent -14 divided by 1.8 exponent -5. 5.56 times 10 to the power of -10. Okay, so you have the value of KB now. 5.56 times 10 to the power of -10 times concentration dia berapa? 0.05 is it? Yeah. 0.05 molar. Don't forget to square root everything, guys. Okay. Time 0.05 and then you square root the answer. You got 5.27 times 10 to the power of -6. So you have the concentration of the OH now. Okay, ni carry forward saya buat dekat sini. Okay, so we have the POH is equal to negative log of OH minus, which is negative log of constant the value. Okay, alright, so negative log calculator answer. So you'll be 5.27. POH is 5.27. So what we want is the pH. So 14 minus 5.27, it will be equal to 14 minus that one, 8.72. Tada! Siap. Okay? Macam begitulah ceritanya. Ya, kan macam ni kan? So, dia start dengan calculating the number of mole. Okay? Kalau kita ikut kita punya preference lah. Sometimes kita tak tahu where to start tau. You guys pernah experience that kind of situation tak? Benda nak buat ya? Okay? Alright. So, kena cari apa yang membantu you to start lah. To start. Step mana yang sesuai untuk you start. Selalunya from the balance equation. Okay, from the formula itself and then kita reverse macam tu. Macam saya tadi kan, saya tak start from calculating the mole. No, saya tak start kat situ. Kita start dekat equation. Okay, so don't worry, memang itu adalah normal. Kita tak tahu mana nak start sebab dia macam overwhelming, too much of information. Okay, alright, so you start from the ni and then from there baru you, aku nak ini. Tapi in order nak dapat ini, kena tahu daripada dua orang ni. So barulah kita find out the mole kan. Barulah kita guna this step. Find out the mole. Okay, and then you have this part just now. And then, kita nak cari concentration tadi. So kita nak masukkan into this one just now. Kita sangkut sebab we need the concentration kan. So that is why baru kita kalau macam tu I have to find out the new concentration. So you have to consider for the total volume. Total volume. Okay guys? Dah dapat? Dan the rest jadi macam auto lah. Ayu 6.06 pukul 6.7 minit sudah. Okay, alright. Any question? This is another. So you have
Kalau bersepah-sepah pun tak apa.
Bersepah-sepah? Sepah pergi mana?
Kan macam banyak sangat benda kan. So macam kalau macam contohnya yang macam kan yang lagi satu kat ice table tu, yang lagi satu tu. Contohnya kalau tak ingat apa dia punya tu macam initial, added, final tu. So nanti dia akan bersepah-sepah lah information ni dekat, tak apa ke?
Dia selalunya bersepah-sepah tu bila you beginners, you baru nak start kan, sebab you tak tahu nak start dekat mana. So you start kat sini kan. Tapi bila you dah buat practice, nanti somehow you akan dapat dia punya trend dia. Nanti dia akan tersusun lah. Okay, sepah-sepah pun tak apalah as long as everything is in there. So busuk-busuk pun kita ni carilah yang mana yang okay ni patutnya ni patut kita cari yang ni ada, everything is in there, it's okay lah, tak apa. Okay, cuma sepah-sepah tu normal. Selalunya it happen at the beginning when we start to learn something new. Kita tak tahu kan nak start from where, then kita start from here and then alah aku kena cari ini dulu pun, kita pergilah tempat lain cari dulu and then come back balik kat situ kan. Tu maksud sepah-sepah awak tu kan. Faham, tak apa. As long as everything is in the same page, Okay. Okay. Calculation tu. Okay, lagi ada soalan?
Madam.
Any question? Try You guys have to try this one. Okay, you cannot just
Madam.
Ya.
Equation yang wajib ada untuk question ni, so dua je lah kan. First yang equation untuk titration tu, dengan second yang salt dissociation tu je lah. Yang tu kan.
3. Ini dia tak tunjuk dia, sorry. Mana tadi? Baik. Satu. This is the titration, the neutralization reaction. Second, the salt dissociation. And then the third one is the salt hydrolysis. Ada 3 lah. Betul tak? Dia kalau salt, dia mesti ada this salt dissociation and salt hydrolysis. Cuma since the salt tu, dia initially they come from the neutralization process. So far yang kita buat sendiri yang sebelum before this titration, kita assume that, bukan assume, the salt is already given to us. Dia tak cakap pun from this acid base titration and whatnot, dia tak cakap, dia tak mention. Apa yang kita ada adalah salt. But this one, the salt is produced from the acid-base reaction. So that's why kita kena ada acid-base reaction dulu. And then kita take the salt will dissociate. And then from the dissociation, kita take the one that will be hydrolyzed and then undergoes the hydrolysis. 3. Kalau kita buat salt hydrolysis last time yang sebelum kita belajar titration, you only have 2 sahaja. Okay. Right, any other question? Tak ada
Clear madam.
Okay, clear Try okay guys. Try. Okay, and then lepas pergi buat final terus. Boleh jawab tak? Okay. Alright, so that is all. So we have one more checkpoint to be discussed next week. So we'll discuss that checkpoint next week. So with that, I end this session. Okay. Thank you everyone for your cooperation and attention, and Assalamualaikum. Bye-bye.
Thank you, madam.